Welcome to Ask CTE Contributors. My name is Timothy Spaeth, and I'll be hosting today's session, Mastering Large-Scale Machining, Baker Industries Innovations and Strategies. Now, this webinar is based off a weighty matter, which is an article in the October 2024 issue of Cutting Tool Engineering Magazine. You can find that at digital.ctemag.com. A little bit about our presenter. Brian Baker continues his family's 30-plus year legacy of advanced manufacturing excellence as general manager of Baker Industries, a Lincoln Electric company. Today, Brian will offer an overview of how Baker Industries combines innovation, precision, and reliability to meet the demands of large-scale machining and heavy manufacturing. Let's hear how they're shaping the future of advanced manufacturing. And feel free to ask questions whenever you want during the webinar. Brian will answer them as they come in.
All right. Thanks, Tim. Appreciate that introduction. And hello, welcome to anybody listening live or listening in the future. Appreciate you taking the time to hear what we have to say here. So like Tim said, going to walk through some of what we do here at Baker. Really, the intention is to share some of the industry, large scale machining challenges and opportunities. I do have a few slides on here about Baker Industries specifically to just give you some more background about who we are and what we do. But the intention is really to talk more generally about large scale machining than just Baker Industries. But like Tim said, I am a son and nephew of the founders. So Kevin and Scott, they started Baker back in '92. And really the company started as machine shop for duplicating and has grown, which I'll share with you in a minute. But just a little bit more about me. Went to school, Michigan State, degree in finance, which was fun. Went to work in accounting for several years, and then came back here one day. It was actually like a Christmas night after being with the family. My dad brought me up here to show me what was going on at Baker since I had left. It had been probably about 10 years since I had seen the company. And what I saw was incredible growth. There was more machines, there was more customers, more tools and things going on than I had seen before, and really got me excited about manufacturing and about Baker Industries. So I asked for a job. I said, "Hey, I'll do anything. I'll be a janitor, whatever. I got to get in here." So I started as a project manager, which was a great position to learn all different aspects of the business. Went on to spend some time as CFO. And then once, as you'll learn a little bit more on the next slide, Lincoln Electric acquired us. I moved from a finance position over to a general manager position running the business. So a little bit more about Baker. Like I said, started in '92 and really focused on machining. That's our core competency. So spent many years just being contract machinists and doing work for a lot of tier ones and tier twos in the tooling industry, automotive dies, automotive tooling, eventually aerospace tooling, and then making our way up to be a tier one supplier to a lot of those OEMs and primes. About 250,000 square feet now, 250 employees. And again, on Lincoln Electric, they acquired us in 2019, and we are part of their Additive Solutions division. And you might, if you know Lincoln, you might be kind of wondering, what does Lincoln Electric, a world-leading welding company, what do they have to do with machining, right? So their Additive division, like I said, is 3D printing really large metallic components. And part of that needs some post-processing, machining, and then as well as, some welding, some inspection, NDT, things like that. So we really became an arm for them to help them finish up their projects. So they acquired us to really post machine and ultimately sell a finished good to the customers, not just produce an additive component. And I'll share a little bit more about that later. But if you're wondering what large scale additive means to us, that's where we're talking about parts that are at least several feet, if not, up to 10 feet in diameter, and hundreds, if not thousands of pounds. We can go up to about 22,000 pounds. So this is what we look like today as far as the Baker campus. The Lincoln stuff I mentioned before, right? They're a global company, locations all over the world. Um, Specifically, the Additive is located in Cleveland, Ohio. But as far as the Baker campus, this is what we are: 5 buildings here in the Detroit, Michigan area, Macomb Township, specifically, if you're familiar with the area. And we've grown over the years, adding. We've had good luck with buildings being nearby. But just a quick overview: Plant One, that's all of our machining. So all of the CNC machines and anything I talk about machining related today, that's occurring there. And then Plant Two, that's all of our heavy fab. So all of our welding, saw cutting, bump forming, water jetting happens over there. And then Plant Three and Four, that's where we kind of split between uh, tooling in Plant Four and components or parts in Plant Three. So both of those plants will use machining and fab services from the other buildings, and then they'll do either focus on tooling like aerospace, fixtures, layup molds, assembly tooling, automotive, large vehicle bucks out of Plant Four. And then out of Plant Three is where we really focus on hardware like aerospace, flight hardware, a lot of machined components, and that's where we will do some machining, but we will also do final inspection. We'll do NDT and all the assembly, and we also are building shipboard products out of there for like the Navy and other shipbuilders. Plant Five out in the background, that's more of a standard product we build, Lincoln Electric cobots. So Plant One through Four is all custom manufacturing. Plant Five is a more of an assembly line type setup. Last slide or so on specific to Baker before we jump into the general machining discussion, but wanted to make sure we kind of share with you guys, all right, why should you be listening to us? Where's our credibility? And what do we have to do with large machining? So we've got a ton of small machines and a good amount of medium ones, but we wanted to put up on the screen the largest machines that we have to show you what we can do. So that Metcalf Power Mill on the top left, we can do about 50 feet by 20 feet on that machine bed and 10 feet under the spindle. The Echo Mill, we've got about 30 foot, and that's a horizontal. And then the bottom left, we've got 2 new power mills that are getting installed as we speak. They should be operational by the end of the year. And those we can do about 26 feet by 13 feet. And then to the bottom right, some Breton mills, wide range of stuff there, anywhere from, kind of 10 feet to close to 30 feet. And those are some of our more legacy type equipment, where some of the power mills are new things that we're bringing on. But we've seen a lot of applications in some of the industries we'll talk about coming up. But as you can see, adding 2 new power mills in 1 year, we're seeing a lot of growth, a lot of opportunity, and a lot of reinvestment from Lincoln back into all of our companies, but specifically here at Baker. So a little bit more on the industries that we serve and that we see, large scale machining really come into play. Aerospace and defense, that's our biggest one right off the bat. Typically, a lot of what we see on the really large side is tooling. So a lot of big layup tools and mill fixtures could be for like a wing or a fuselage. And then we also see where those would have like a lot of complex, more of a single part, but complex shape and geometry to it. And then we also see a lot of assembly tooling where maybe there's hundreds or even more components being built up into a large assembly tooling to help customers be able to hold their parts, put them in position. But a lot of times with that, there would be a main frame that comes with that assembly tool. So a lot of times we'll do welding of the frame, machining of that frame on one of our large machines, and then all of the assembly of the smaller details over in Plant 4. Also in automotive is again where we see some large tooling, not so much the parts, but some of the large injection molds. We've machined a lot of those over the years. and then vehicle bucks or like dupes or duplicates of future model years. So those are often full size, full scale representations of vehicles and can be made up of several components, typically large pieces of aluminum for internals vehicle bucks, and then large steel frames for external. Shipbuilding, that is definitely some really large components. Some of that even, far exceeds what our capabilities are. But we see a lot of the large or medium sized shipbuilding things that both for the Navy and commercial use, research vessels and things like that. And that's been an area of a lot of growth over the past couple of years. And I think that's going to continue into the future. The energy side is something that we've seen a lot of work the past couple of years. There's even oil and gas not mentioned up there. A lot of the oil rigs, TKY joints, things like that. But specifically on the nuclear and more specific the fusion side, a lot of investment in that area. A lot of different designs, tokamaks, and different things that are being developed. And it's kind of like a new space race to see who can come out with a fusion reactor. So there's a lot of large scale custom components to build these. Just the frame of the machine, some of the components that go into that to produce the magnet that would hold the plasma. So some really complex parts and some really unique alloys there. So in addition to all of those industries and just being a general part of the industrial base, I think there's some pretty clear, why it matters. Besides just the economy, a lot of this goes into defense applications, which is important to have here in the U.S. So a lot of that shipbuilding and aerospace is related to the defense industry. And then from a pure business standpoint, there's a limited number of suppliers out there in the world that have large machines. And especially if you combine it with other services, we've taken the route of, welding, design, assembly, and that gives us the opportunity to offer more turnkey solutions. There's certainly other capabilities that we don't serve, heat treating or, certain coatings. So there's different avenues you can take, but certainly we think that pairing other services with large machining gives you a unique position in the marketplace where you can really deliver value for your customer, and you ultimately won't have as many competitors as if you were participating in some of the smaller machining. So some of the challenges, or at least the ones that we've encountered here, wanted to talk about. I do have slides that kind of get into these items a little bit further, but just in general, right, the size and scale should be obvious, right? We're talking about large stuff, but there's a lot of day-to-day things that come with that, which we'll talk about in next couple slides. And then precision, right? To maintain something on the machine accuracy, the larger it gets, the more error there is in the machine just physically, and then the harder it is to be able to inspect that from a quality standpoint. And then workflow. Workflow is something that is difficult when you're talking about really large, unique structures. There can be a lot of time in procuring materials, a lot of time in maybe welding them up or designing them. And there's no room for error, no room for scrapping product when you're making something that might take weeks or months or even years to produce. So being able to have a good workflow from the beginning is very important. And a lot of times there's a lot of engagement with customers. There's a lot of design changes that happen along the way that we need to be flexible to be able to support. So getting into those a little bit more, the obvious one that we mentioned, the part size and scale. So just maneuvering parts can be a challenge, and that's something that we've noticed ourselves. Right, we've had instances where we've needed to put in larger doors. We've needed to put in larger cranes. There's a lot of times where we will have to build custom crates or tooling just to move components between our facilities. And then, of course, ultimately shipping to a customer can be difficult when we're talking about, extra wide loads and weight considerations, frost laws, things like that. So we try and address a lot of that upfront with our customers and understanding, okay, if even once we build this, there's the complexity of delivering, installing, and things like that. Some of the solutions we've done in the past, a lot of stuff we produce that's smaller goes out in wood crates. But some of these things are so large or so heavy that we have to actually build custom aluminum and steel crates for either over the road or for ship transport to the final customer. And then on the pure machining side, having machines large enough is pretty obvious. But one thing that we've noticed is having machine beds that are maybe even larger than your anticipated part size. What I mean by that is a lot of times customers have programs that go on temporary hold, and doing setup on those jobs is sometimes a lot of time. So having a machine where you can leave something set up and move on to machining a different part and then come back to it is the kind of flexibility that you need from a machine standpoint to be successful. And then, of course, just other general just facility square footage. A lot of times these parts need to be flipped over to machine both sides. You need big, heavy cranes, and you need a lot of space. Almost for every machine, you need a similar size empty floor space to stage or to be able to flip parts over and prepare them for machining. On the quality control side, this is something that you get a little bit more unique um, needs when we're talking about, small and medium parts. A lot of times we can check those on a CMM, coordinate measuring machine. When we get into these really large, either components or tools, typically we're going to use like a portable solution. So something like a laser tracker or maybe like a blue light scanner come into play. And then you have additional challenges with the accuracy of those machines over greater and greater distances. So engaging with the customer, making sure they understand the limitations of the equipment, where a customer might be used to, one thou or half a thou, test accuracy ratio on a CMM. Maybe they need to be made more aware that, we're talking about 3-4 thousandths on a laser tracker over, a distance of 32 feet or whatever your part might be. So a lot of that is educating and understanding our capabilities up front to make sure that we set the expectations with the customer at what we can do at the end of the day. And then another big part of having good quality is performing in process inspection. So when we're dealing with these parts that it's maybe one of one, it may never get made again, or a handful of them are going to be made this year and that's it. Especially on like the tooling side, or if there's anything to do with like high value material or long lead castings and things like that, we have to do in process inspections, and we do those throughout the machining process. So we'll talk about doing best fit and scanning before we even start, thinking about putting on a machine. And we'll do inspections, at least spot checks after rough machining. And we'll do that also after semi and of course after final machining. But we do these along the way. And really we want to do these to make sure that there's no issues that are coming about. And it gives us an opportunity, if we see something happening, we can fix it. So that's a good idea when you're dealing with anything unique, one-off, large, hard to replace. Let's check it as we go, and then the ability to do stress relief, depending on the customer's application. A lot of times it might be required. If it's not required but it's allowable, we like to give that power to our machine shop manager and use the experience that he has and the knowledge watching how this thing is reacting as we're machining to go for a in-process stress relief. Another good tool that we have there to maintain quality is fixturing. So when we're doing something complex that might have, might be a little bit large, but it might not be robust, we can design fixtures in house. And those, again, can be helpful for transportation, but can also be very useful for the machining process and for the inspection process. So bottlenecks, right? So this is definitely an issue when we talk about large scale machining, because there's not a ton of machines out there in the world, right? So if we were to have an issue meeting customer timelines, there's not a lot of relief valves to go to. And there's also oftentimes with these large projects a lot of opportunity, like I said, for changes, and programs get put on hold and then they come back on hot when you have other things working through the shop. So the way that we've addressed a lot of this is redundancy in our machines. So we are at a spot now where we like to buy, if we're going to buy a new piece of equipment, we like to buy two. Even if maybe our program is requiring one at the time, we see opportunity for growth and we see a need to have that backup. If one machine goes down, or volume increases, rate increases on something, or other work comes in, we want to have that ability to move to a different piece of equipment. And then, like I mentioned, with machines, the maintenance side, potentially machines going down, right? Having our own in-house maintenance is huge for us. Obviously, new machines, we want to work with the manufacturer for any warranty they have there. But having somebody on site here that knows all of our equipment can speed that process up with the OEMs. And then that person can take care of machines that are out of warranty, make sure that we have preventative maintenance plans in place to eliminate downtime. And then the other big one is just capacity scheduling. And that's something that we can all always, everybody can always do better at that. But that's something where we like to look at what all of our load is on these machines, and we try and operate in a fashion that gives us some flexibility there and visibility to the customer. One thing that we've noticed on large components is a lot of supply chain issues on material, especially if we're talking about castings and forgings. And sometimes those are for a specific component, and sometimes those are for tooling that we're building. So what we've been able to do is use our additive technology with Lincoln to replace some of those traditional material manufacturing processes. So that gives us an opportunity to pull ahead what maybe was several months and turn it into weeks just to get the raw material so we can start. So of course, anytime you can get started machining faster, you can produce your end component faster, which has been a big success for us. And then the ability to do both, really. So we can use traditional manufacturing and the additive manufacturing. It's not a one size fits all. We have all the tools in our toolbox. And another important thing I've got a note up there I want to mention is our machinists. When we're dealing with these unique one-off opportunities, having somebody that can do the programming and the operation of the machine is critical to us. If you're running, production, thousands of parts, maybe it makes a lot of sense to have a programmer and a machinist operator that are separate. For us, it's one and the same. And the person that is at the machine, listening to how it's reacting, watching it, understands all of the needs, the tolerances at the end of the day, is also on the floor writing the program and intimately involved with that project from beginning to end. So with that, wanted to talk a little bit about some of the trends that we are seeing on the large scale machining side. So definitely back to additive a little bit here, right? The sustainability. So material waste, we're seeing customers 3D printing parts on their own with some existing technologies. We're seeing customers come to us with problems and asking us to 3D print those to reduce material waste or reduce timing there. and then a lot of material type, right? So probably 5, 10 years ago, almost the vast majority, almost 100% of what we were focused on was aluminum, steel, and Invar. And today, um, some of our business positioning has changed, but I think a lot of the market in general has changed to more super alloys, looking for more high performance, lighter weight. So we see a lot of titanium, see a lot of Inconel, see a lot of stainless steels, going into critical defense and energy applications. Just the material demands are increasing, and that's something that really on the tooling supply side is something that you have to be aware of, and make sure that you understand how to cut those materials. They're going to perform differently. Uh, Automation side, this I think everybody in the world knows this is going to be huge, and part of it is how do you automate large scale, right? That gets more and more difficult. But we did make our first entry into an automated machine this year, and it's been very successful for us. It's a more of a small medium 5-axis mill, but we're taking that as a test bed. We're looking to see what does that perform, and how do we start talking about turning that into larger and larger applications. There's not too many options out there in the world yet for the machines, but I think that'll continue to grow. And then in the meantime, what else can we use automation for? Maybe not specifically, pallet changing CNC machines, but can we use it on, the maintenance side? Can we use it on the inspection side, right? So a lot of, medium sized parts, can we run lights out CMM inspections on? Can we cut lights out? And then even on the software side for scheduling, that's been a big focus of ours in the past year or so. How do we get better at scheduling these long runtime jobs? A lot of complex design and things goes into them. And then how do we react and make sure that when there's changes or things put on hold on and off from a customer, how do we clearly understand what that impact is to our schedule, so we can make sure that we have the right information flowing back to a customer. So anybody looking to get into the large scale, I think, needs to understand there's a lot of variability, and sometimes it can get to be a lot for a single person, or even a Microsoft project schedule type thing to handle. So I think leaning on software to help us with the workflow through different departments is a big deal. And then a big thing that we see coming in the future is a lot of model-based definition, less reliance on prints, and a lot more going straight into the CAD model. And that's both things we're being asked to design ourselves from customers, and that we're moving into with them, and then just build to their specifications, where customers are providing all of that FT&A and GD&T and all of that information in a model. So that's something that everybody needs to be prepared for, to be able to perform that type of work without having any drawings made. And then it's certainly something that the customers are pushing for efficiencies. The part in the bottom right here, I just want to point out, I'm certainly no AI expert, but that one is kind of interesting. It's a NASA part that AI was used to help generate generative design, and that's on our machine. They're being machined with an FCS system, which, if you guys aren't familiar, that's another great work holding tool. But that part's unique, something new with the AI coming. So some takeaways for you. I talked a lot about redundancy with us. It's multiple machines. When we're talking about large scale machines, let's have multiple that we can go to within the company. There's always a need for that. Automation, we talked a lot about, both on the machining side, what's coming, and then on the software side. Scalability. So this is where we really want to focus on how do we make things faster and and be able to do that efficiently in our process. So that's, again, leaning on software, but it's also growing just with machine count, right? We've added 8 machines this year. Our additive business is continuing to grow. So being able to add into our existing facilities and kind of use our existing culture and management to continue to grow there. And then quality is a must, right? So again, when you're dealing with the industries, aerospace, automotive, energy, shipbuilding like that, quality is an absolute must. And not only is it a requirement from your customer, our customer, is it's the right way to run a business for profit and for employee morale and safety and everything. So something that we build into the beginning, but really would encourage everybody to take quality, AS9100, ISO, NADCAP standards, and make those a big part of, any quality management system that you have. And then emerging technologies, right? We talked about additive. That's kind of where our key go-to-market strategy is, the really large scale metallics, printing steel, Invar, Inconel, and so on. And maybe there's, other technologies out there for different companies. We touched on AI, if that's something that somebody has a really strong suit in, or software programming, maybe that's the technology that they leverage to have a really good position in the marketplace. But I think you need something more than just large machines to be successful, right? There's so much, just even on the human capital side, so much talent, so much training that needs to be done to transfer some of that knowledge to the next generation. But there's so many other things, right? The post processing with inspection and coatings and NDT, heat treats. So I think there's a lot of opportunities out there to pick a specific technology and combine that with large machining to be successful. This we wanted to share. These are some of the key suppliers to us. So a lot of the machines that we looked at today, MCO/MECOF machines, has been a great partner of ours. If anybody is interested in making connections there, we know those guys really well. And then, on the control side, FANUC and more recently the Heidenhain controls is where we've been focusing, trying to standardize around one or two. I think is important. A lot of ability for machinists to transfer between different assets. So if somebody's out or, vacation sick or whatever the case is, a lot of our guys are cross-trained and can jump over to that machine and keep it running. And then on the tooling side, a lot of people probably know Kennametal and Polcom, but been great partners of ours. And, a lot of opportunity if you get to know those guys, where they'll help you understand what tooling you need to be successful. And they're also, a great opportunity to go, get some R&D type of capabilities with them, so they can help provide some cutters for you to do testing with, and provide information on, studies, time studies, things like that. FCS, I had that one picture of the NASA part. So flexible clamping system. This is something that we use as much as possible. And it's just a fast way to be able to hold parts and integrate holding features into parts. Sometimes customers are okay with those features continuing on and staying with the part, in which case, if there's ever changes, it makes it very easy for us to get back into that component and set it up and machine any changes in. Sometimes maybe it's not an application where they can leave those fixturing holes or whatever in. And in those cases, of course, we take that into consideration and either would not use FCS or use FCS just kind of in a roughing stage and be able to machine away those features before we get to the final product. And then CAM software, we use WorkNC a lot. Hexagon's been a great partner for us on, the Polyworks side for CMM, as well as some of the, Vericut type stuff to make sure that what we're doing from a simulation basis before we go into machining is accurate. So just bringing it back to Baker, just want to offer, anybody has any further, or anybody has any questions, happy to answer those here or in the future. can reach out to us and get a hold of us, and we can help either maybe directly with a project or just share some of our some of our experiences to help you. Uh, yeah. So with that, that's what we have. I don't know if there's any questions there, Tim.
Doesn't look like any questions came in during the live recording, but we did have some questions come in ahead of time, which would be really cool if we could go through those.
Sure.
So I'll read you those and feel free to answer. So, can you elaborate on how hybrid manufacturing is integrated into your workflows and what benefits it provides for large scale projects? And I know you definitely touched on that. So.
Yeah, touched on it a little bit, but I can spend a little bit more time on it, right? So
Okay.
for us, again, want to really focus on that word hybrid manufacturing, right? So we don't look at anything like, hey, it has to be additive. We look at, all right, is there maybe an entire piece of this, or maybe even just small parts of a tool? A lot of times aerospace tools, there might be a large flat section and then a portion of that where it has some complex geometry. Let's look at just printing that complex geometry, welding it to the more flat plate, and that gives us an opportunity to really drive down timing and cost without trying to say additive is the solution for everything. Um, and then there's certainly applications for just full replacement of long lead castings and forgings that might take months or longer to get that we can print in weeks.
Interesting.
And a lot of
So,
times it's about timeline improvements, right? Sometimes it's a good cost savings, but more often than not, like timeline is where we can make the largest impact for customers.
okay. How do you address issues related to thermal expansion and vibration when machining large components?
Yeah, thanks. So I think number one is a temperature controlled facility. So all of
Okay.
our facilities, 100% temperature controlled, heat, air conditioning, humidity. We want to keep that steady so that material's not moving around on its own. And then inside of the machines, temperature controlled coolant when we're using it,
Okay.
and then compensation on the CNC machine controllers and the laser trackers and CMMs for when we're doing inspection. Those are some of the the kind of big answers, but then there's a lot of things that would apply to unique situations. Maybe there's where our machine manager would come into play, right? His experience. So, are we going to flip parts back and forth and kind of sneak up on certain aspects of it, and be paying attention to the heat input to the part? So maybe we'll break a setup loose several times, check for any thermal expansion or warpage that's happening, and then address change our machining strategy. So many of the things we make are one off, right? So we kind of have to baby it sometimes and make sure that we're checking it throughout the process, and that might mean lower removal rate as we come towards a finishing operation. And a lot of it comes down to just a really good setup, especially on the vibration side. So whether that's traditional clamping using FCS, getting creative with nesting, either aluminum, hard tooling, or some kind of Ren board or wood or something like that to get a really good nest to eliminate vibration.
Okay. Thank you for your insight on that. That was a great explanation. Um, the next question: what are the maximum part dimensions and weights your largest machines can handle?
Yeah, so the pure size wise, right? It's that power mill in a single machine travel. We can hit 45 feet by 19 and a half feet by about 10 feet tall. Um, there's been a lot of instances where we've had parts longer than that, not that wide. Maybe they're 4 feet wide, but they're 50 plus feet long, where we can slide the part, machine part of it, break down a setup, slide it, set it up with a laser tracker and get back into machining it. And then on the weight side, it's really more about just the part handling. That machine table probably could handle a million pounds or more if you spread it evenly across there. Um,
Wow.
so on the weight side, you start running into more about those facility issues, right? What's your max crane capacity?
Mm.
What's the size of the part? How are you going to move that part between buildings or to your customer?
Yeah, so that was a big theme of this presentation. Some talking more about just the machine, the whole flow of the workflow of your operation. It's really
Right.
interesting. How do you handle the machining of exotic materials like Inconel, titanium, or Invar?
Yeah, so this a lot of this is kind of the experience and tribal knowledge of our machinists and our machine manager. Our machine manager has been here for the entire time, so he's got 32 years with us and really understands how these materials react. But beyond that, it's having relationships with the tooling suppliers that I talked about a couple slides ago, right? Kennametal, Polcom, there's others out there, but trusting experts. So we might be experts in certain areas, and there's others out there that know a lot more than us in others. So let's not be afraid to reach out to them, trust their recommendations, and then get some cutters in here and do a lot of testing. How deep can you cut? How fast can you cut before you start getting issues? So really, it's just not being to us. It's not being afraid to just try new things. And now that we've done a lot of that over the past 5 years, where I mentioned the transition from steel and aluminum to Inconel titanium and Invar and stainless and others, we've built up that kind of knowledge base within the company that these are no longer really they're almost no longer even exotic to us. These are pretty much everyday materials now.
Wow. How do you manage workflow alignment across your machining, inspection, and finishing processes to minimize bottlenecks?
Yeah, so this probably could be an entire webinar series in itself. But a couple key things. I won't get too much into it, but there's a Lincoln business system that a lot of the Lincoln companies follow, and that's something that we were brought into after the acquisition. So there's a lot of knowledge there to be gained. But some things that we do here on site, right? It's a weekly meeting, in depth, every single job, every single department, where we're spending several hours talking about everything in the shop. And then there's maybe even more importantly, there's a daily tag up meeting every morning at 8:30 that all department managers, we call it T-Rex, timing, resource, and execution. And we're going to talk about every job that's due in the next 2 months, any jobs that aren't kicked off yet, and any job that anybody has thrown a red flag on. And that tag up is going to give us the opportunity to make sure that nothing sits for more than a day. If there's an issue going on, we can get after it, and everybody is on the same page in the room at the same time.
Wow. Yeah, that's really good piece of knowledge right there, and I'm sure a lot of people in our audience could definitely benefit from hearing that, and maybe even apply it to their own operations. Um, so, how does your experience in aerospace machining translate to projects in other sectors?
Yeah, so we really kind of have grown into a full service company on aerospace tooling. Since then we've leveraged it into aerospace flight hardware, Navy and shipboard parts, energy, and so on. But for us, it's really that tooling aspect is where there's a lot of flexibility needed. Every job is somewhat different than the previous one, and we had to build a culture around that, right? Where it's a lot of low volume. We might only make a part or a tool once or twice, and there's a high mix every day. There's a different tool that we need to think about. How are we going to manufacture that? So that culture, that skill set that's been built here, that fits really well with certain industries that have those similar needs for flexibility, high complexity but low volume, right? So some automotive tooling can fit there. Certainly, energy, shipbuilding, heavy industries that I mentioned, aerospace. Uh, but we also are honest about where it doesn't fit, right? So if it's the appliance industry or the automotive parts industry where you're going to make thousands of parts or maybe millions of the same part, right? Our business isn't going to be a good fit for that type of task. So we just approach it, clear and transparent with the customer. Where do we fit and where do we not fit? And we really focus on where we can deliver value.
That's good. That's really good value to have as a company. Um, with increasing demand for precision and speed, how do you ensure scalability without compromising quality or lead times?
Yeah, this is a tough one, right? Because everybody wants to take on more and more work, and really for us, it's about growing the business. And we've added 8 new CNC machines this year, and
Wow.
but along with that, we got rid of some of the old stuff, right? So if we want to increase precision, and speed on the machining side, we need to grow, add equipment, but then we also need to let some of the legacy stuff go.
Yep.
And that sometimes can be hard to do, right? There's machines that have performed well for us, and there's operators that know how to run those machines great, and there might even be a sentimental attachment to some of these things, right? Like maybe my dad bought one of these things 30 years ago, and now I gotta
Yeah.
rip it out of here and put something new in. So there's a lot of things that can stand in the way, but really it's just about evolving, growing the business, not being afraid to move forward there, and then making sure that we're hiring and retaining key talent. That's a huge part of our success is the people here with the type of work that we do.
And with that, if you guys want to reach Brian Baker, you can email him at brian.baker@bakerindustriesinc.com. And definitely check out their website, www.bakerindustriesinc.com. Thank you so much for joining us for this webinar. Brian, if there's any last remarks you have, feel free.
That's it, Tim. Thanks for the time, and hopefully we get some people reaching out to us. Would love
Awesome.
the opportunity to be helpful.
Make sure to check out our webinars coming up in 2025 and feel free to leave a comment because your feedback matters. Thank you and have a great rest of your day.